Hello and welcome to this live stream here today. My name is Daniel Myers, and today I am really excited because we have some big things to talk about, big things to show you with demos, big announcements from Snowflake, all around improved developer productivity and specifically Python developer experiences. With me today, I have the one and only Jason Freeberg, Product Manager here at Snowflake. Jason, how are you?
I'm doing well. Thanks for having me.
Awesome. I am so excited to have you on the stream today and show us as the product manager, responsible for all these different things at Snowflake, get hands-on with some of these new Python features and capabilities. So to really kind of kick this off, tell me a little bit just about yourself and kind of what product areas and things like that. What do you work on here at Snowflake?
Yeah, sure thing. So I'm a product manager here at Snowflake. I work on the Snowpark team. And so our team owns all of the libraries and runtimes to run non-SQL code on Snowflake. So of course, that includes Python, and that's what we're going to be talking about today mainly. But that also encompasses running Java, Scala, and JavaScript on Snowflake. And so in particular, I own a few features. Today, we're going to be talking about user-defined aggregate functions, or UDAFs, and the local testing framework for Python. I also work on telemetry and observability for Snowpark and our Anaconda packages, our partnership with Anaconda.
Fantastic. So, so you're so close to, all of these different product features that touch developers, right? Kind of at the heart of developer experience for Snowflake. Tell me, in your own words, how do you think about developer experience and how do you build for that in Snowflake as a different product and features?
Yeah, I mean, we work very closely with our customers and we listen very closely to the feedback from our Python users. And so these two features that we're looking at today in particular grew out of some of the direct feedback that we heard from our users. So specifically, user-defined aggregate functions, as we'll see, it makes it a lot easier to write custom aggregates in Python. And you could do that previously with UDTFs or table functions in Python, but it wasn't the easiest thing to do, and it also wasn't incredibly performant. And so this is the next evolution of all of our user-defined functions that we have for Python on Snowflake. And likewise, with the local testing framework, we heard from our users that testing with Snowpark can be difficult. It can be sometimes a little bit slow. And so that's what the local testing framework is there to solve, is to make it easier to test Python and make your workflows and your day-to-day interactions with Snowflake a lot easier and faster.
That's awesome. I mean, local testing it really across the board helps to get that from thought to action motion faster. That turnaround to immediate gratification. Local testing really helps to enable and speed that up. And so the one of the things that I saw, right, is that we have this area here, this announcement blog post announcing general availability of Snowpark Python local testing framework. And you wrote this, which is awesome to see. And so just dive in a little bit. So we have some of the key benefits here and how to get started. Tell me just a little bit more about, if somebody really wants to, if they haven't done local testing for anything related to Snowflake, what are some big, high-level tips to help get started, it seems like?
Yeah, so the local testing framework under the hood, effectively, it allows you to run your test suite for, say, a stored procedure or for a UDF without having to connect to Snowflake. So in that blog post there's also a link to a tutorial. And so it shows you how to take a stored procedure, a UDF, and how to take tests that you might have already for your Snowpark project, and then how to just tweak those existing tests to use the local testing framework. And so what the framework allows you to do is effectively run those jobs locally in sort of an ephemeral session, and then your stored procedures run locally without connecting to Snowflake. You can also create tables within this local session. They're deleted after the session terminates. It's all just in memory, kind of like SQLite for, say, doing app development. but it allows you to spin up an environment locally, run these tests with something like PyTest, and that's what I'll be showing later today, and then ultimately promote those tests through a pipeline. Because as we'll see, you can just run your tests locally, and then without changing any of your Snowpark code, you can run that same group of tests against your Snowflake account. So it makes it really easy to run these local tests on, say, every pull request that's submitted to your repo, but then you can still run the whole test suite against your full Snowflake account before you, say, cut a release. And you can do those full tests with your full account on a slower cadence, so you're not using it on every run.
That's awesome. That's awesome. And so, as we kind of move forward here, why, we kind of talked about some of the key benefits, but why did you kind of build this, and over other, there's so many different priorities, across different features, why build this?
Testing is important. So being able to test quickly and test frequently can help developers be a lot more productive, be a lot more careful in the code that they're releasing. And so without the local testing framework, doing so was somewhat of a burden without the local testing framework. And so this makes it a lot easier to get started with writing tests for Snowflake. And you can also iterate faster, because previously, without the local testing framework, if you were, say, running a test for some UDFs and a stored procedure, that script would have to connect to Snowflake on every execution. And that can add up over time if you're trying to iterate quickly as you're writing that UDF or that stored proc.
Makes sense. Makes sense. So let's get hands-on. Let's see a demo.
Sure, absolutely. So here I have VS Code open. Looks like it's showing up on the screen now. So this is also the same project that's linked to the tutorial that you had up on the screen just a minute ago. So I'll be going through some bits and pieces of this, but if you, the viewer, want to get hands-on with this and try this out, you can just follow that tutorial, and it goes through all the same key points here. But just to give a quick idea, so we're all on the same page, here I've got a Python project open. So of course I've got my requirements.txt. And then under this project directory, I have this sproc, which stands for stored procedure. And then we can see in here, if you've written a stored procedure before, this should look familiar. It's just a Python method that takes a session as the first parameter. And then this is what I'm going to create and run on my Snowflake account. And then within here, I have a UDF that's created. And then I use a few of what I like to call data frame transformers. So these are just functions here that take in a data frame and then return a data frame. So we can see here that I have 3 of them. And then they just perform some operations on the input data frame and then return a new data frame. So I use those here on lines 27, 28 to create fact tables, which I'm using here the city bike data. It's a fairly popular data set for doing data exploration, doing sort of proof of concepts with Python. And so it has ridership data for a series of rideshare bikes that Citibank operates in New York City. And so here I'm calculating some monthly facts and some per bike statistics. And then finally, I'm writing those out to some output tables in my account. And so here I have this whole stored procedure. I have the UDF, and then I also have those data frame transformers. And so to go along with each of these, I also have my test directory here. And so I have my test case for my stored procedure here. So I set up a table, I set up some input data, and then finally down here, I actually call that stored procedure, and then I run my assertions to make sure that the output matches the expected values. And then I do that again for those transformers. So back in the other data frame I had, or excuse me, back in my other files, I had those data frame transformers for calculating those bike statistics and those monthly facts. So likewise, I have test cases for those. And then finally, I have a test case here for my UDF handler. So all of this is set up with PyTest. And so first, we're just going to go ahead and run this test suite using a live connection. So when I run this PyTest command down here in my console, this is going to create a session with my Snowflake account. And then we'll go ahead and run this now. So right now it's trying to connect to Snowflake, and it's also going to trigger my 2FA. So here on my phone, I'm approving this to log in. And so this is, again, getting to the point that sometimes there are development hurdles with connecting to your live Snowflake account when you're trying to run tests. So I'm going to approve these. And then there we go. All of my tests passed. Things look good. But again, that took some time. I had to go through a 2FA hurdle. If you're using certificates to authenticate to your Snowflake accounts, there also might be configuration set up that you have to do there. So here's what we can do instead with the local testing framework. Underneath my test directory here, I have this conftest.py. This is where I can set up some configurations for PyTest. And so what I have here is I'm setting up a custom option called Snowflake Session. And then if this is set to local, then all I'm doing here is creating a session where I'm just saying local testing equals true, and then I'm creating and returning that to all of my test cases. So you'll notice here on line 11, with that session object, there are no credentials because it's just creating the session locally. It's not going to connect to Snowflake at all. And then what we were using in that last test run was right down here where I'm creating a real session, right? I'm connecting to a Snowflake account. I have this utility function here that gets my credentials from environment variables on my machine. And then that creates a session and I'm able to connect. So now let's go ahead and try running PyTest again. But now I'm going to use the local testing framework. So I'll set Snowflake session set to local. And then when I run this, you can see it executed right away. I didn't have to do my 2FA on my phone, and it only took a couple seconds. So huge productivity gain there. And I'm able to do this as quickly as I want, as fast and as often as I want to. So it makes it really easy if you want to do a more test-driven development pattern for your UDFs and stored procs. That way you can break things out, test them more aggressively, and you can iterate a lot faster using the local testing framework.
This is absolutely beautiful. I mean, I love the simplicity, yet how powerful it is. I think that this is a big unlock for a lot of folks using Snowflake, and it's going to be big. This is awesome. And so I know we covered a little bit about how people can get started. It seems what are some of the best resources that people should go to? So we talked about the tutorial that we have here. And this is the testing Python Snowpark tutorial on our docs.snowflake.com website. We also have the reference documentation for the local testing framework here. This goes over all the reference information from what supported Python versions there are, code snippets on getting, setting up your config and different things like that. And last but not least, we have some general developer guides. So writing tests for Snowpark Python and setting some of this stuff up as well. So Jason, what would be your biggest piece of advice for a developer, looking to dive into this, being at the core of the development of this whole feature, one piece of advice for a developer looking to get in more?
I would say if you're just starting off with testing with Snowpark, or maybe even testing with Python in general, that last article that you had up, I think it was titled Writing Tests with Snowpark. That's a great first resource to start with. It really doesn't talk about the local testing framework specifically, but it provides you guidance on how to set up PyTest, how to use PyTest fixtures, which are a really powerful testing utility that you can use. And that's what I was using under the hood in a lot of the demo that we just saw. So if you're just getting started with PyTest, maybe for the first time, or maybe with Snowpark, definitely take a look at that article first. And then, like you mentioned, we also have the reference documentation for the local testing framework in that tutorial. Once you have a base PyTest configuration set up, I would say then go to those second two articles, and that'll show you how to take what you already have with PyTest and then add the local testing framework to that. And then you can do things like we saw at the very end of my demo there, where I set up that configuration for PyTest. But all of that just builds off having a base PyTest test suite set up.
That's awesome. That's great advice. So moving on to changing topics a little bit, I wanted to now talk about Python user-defined aggregate functions. So what's really exciting here is that this is now generally available. And so what I have open here is a blog post talking all about it. Again, you are the author of this blog post. I'm talking to the one and only Jason Freeberg. And so tell me, in your own words, what is Python user-defined aggregate functions? What are they?
Yeah, I mean, the name kind of tells you, but you're able to create with user-defined aggregate functions any sort of aggregate that you want with Snowpark. So aggregates, those are things that are, some of them are built into Snowflake already, like sum, count, average. And there are quite a few in Snowflake, but depending on the industry that you're in, the business that you're running, you may have very business specific use cases that you want to create aggregates for, but that aren't built into Snowflake already with something like a sum or a count or an average. And so aggregate functions allow you to use Python to describe how you want to aggregate data, say by a group. And since you're using Python and you're using the functions framework, the user-defined functions framework, that means you can also bring in packages, any of the Anaconda packages available in Snowflake. So that opens up a lot of doors to do complex calculations that can be really tough to do in SQL and hard to maintain in SQL, and then put those into a Python code base that can be a lot more manageable, easier to read, easier to understand, and ultimately easier to implement. When we were talking with customers working on this project, there was actually a pretty interesting use case from the company Whoop. They make those sport watches that track some of your biological data, and they wanted to effectively run averages of some of those statistics like heart rate, blood pressure, but they're working on a 24-hour scheme, so they needed to take like a circular average of all of those statistics without just doing them over like a 24-hour period, because your blood pressure might change as you go to sleep from like 11 p.m. to 2 a.m. and they don't want to lose that window. So that was kind of an interesting use case there. And so they used Python aggregate functions to implement that scenario.
That's awesome. I love when we can talk about a feature like this in the context of a real customer problem like that. I think that really and use case, because that really connects the dots for a lot of folks on the power of a feature like this. So let's dive right into this time. Let's just dive right into a demo.
Yeah, absolutely. So this time, here up on the screen, I'm no longer in VS Code. So now I'm using a Snowflake notebook, which again, call out if you haven't seen those already. Snowflake now has notebooks. They're a public preview. Go ahead and give them a try. And so just here in the first cell, I'm just setting up my environment. So I'm importing some packages from Snowpark, and then I'm also instantiating my session object, and we'll be using that in some of the later cells. But now here, in this next cell here, this is where I'm actually implementing a user-defined aggregate function, or UDAF, as I'll probably start saying. So here we're doing just an average. Now, again, that is a built-in function in Snowflake, of course. Like there's an average function in Snowflake that you can just call in SQL. We have a more complex example coming in just a minute, but to introduce the interface and how to write these things, we're just going to use average because everyone's already familiar. So if you want to calculate an average manually, then you need to keep track of the sum of what you're trying to take the average of, say price, and then count how many instances of those prices that you're counting up. So here, The first thing that you'll need to implement with a UDAF is called the aggregate state. And so here, that's where I'm just instantiating two variables, a sum and a count. And then that's going to be used underneath the hood. When this UDAF is called, there's going to be multiple instances of the aggregate function running, and they're going to incrementally aggregate these, in this case, the average for us across all of our rows of data. And then those aggregate states are going to be accumulated, as we can see here, that's the next step, from those intermediate states. And so here, what we're doing is just aggregating or accumulating all of those little aggregate states. So of course, with sum, I'm just taking the sum of one aggregate state and then adding that to the other one. And then with count, now we just want to increment the counts. So I'm not adding the count from the other one, I'm just incrementing those as they go along. And then finally here, when we merge these two together, now we're just going to add the sum to the other sum. So now I'm taking two, we're going up the tree, so to speak, and we're merging the aggregate states further. So I'm adding the sum to the other sum and then adding the counts together. Again, this is just implementing an average, so fairly straightforward here. You'd probably just be using the built-in average function. And then finally, at the end, there's a finish method where you can do any last edits on the data before you get your final result. So here I'm just returning the sum divided by the count, because of course that's how you calculate an average. And then once you've written this class here and you've implemented those properties, you can use the Python API to create that UDAF. So I've already executed this cell here and given it this name, Python average UDAF. And then I can just call this here in SQL. So I've got just a basic little data set here of some prices for cars and motorcycles. And then I can do a select on that table, calling that UDAF, and then grouping by item. And so if you run this, that's one of the nice benefits of using UDFs, is that you can encapsulate all of that complicated Python logic wrapped up in a simple SQL method. And then anybody else in your company and your organization can use that Python aggregate function or table function or UDF without really having to understand all the complexity that's happening behind the scenes. And then there we go. As we'd expect, that returns the average price for the cars and the motorcycles. And then this is linked in some of the blog posts for aggregate functions and some of the documentation. But I just wanted to show this real quick. This is also walking through the average example that we saw just a minute ago, where, again, down at the bottom, we initialize our aggregate state with the sum and the count. And then all of those are getting incrementally accumulated. So we increment the count, and then we add the sum to the running sum. And then finally, everything is merged together at the top. And then finally, the finish function allows us to do any final calculation before the final result is returned, which of course is just doing the sum over the count. And then ultimately the final result is returned. So again, just an average, you'd probably just be using the built-in SQL function to do that. We've got a more complex example that I'll pop over to right now. And so in this case here, we're importing the Apache Data Sketches library. This is a Python package that's available through the Snowflake Anaconda channel. And Apache Data Sketches allow you to use statistically accurate approximations for some statistics that can be very difficult or costly to calculate deterministically across large data sets. So if you're working with billions and billions of rows of data and you want to calculate, say, an average or a count of all of those records or a sum, it can be costly to actually do that across massive, massive amounts of data. So data sketches has a bunch of utilities and libraries to help calculate statistically significant approximations to those values. So this is an example where we're leveraging the Python ecosystem, and we're using, in this case, data sketches to help us do a very custom specific aggregation. And so in this case here, I'm using what's called the HLL sketch. I'm instantiating that on the class initializer here. And then the aggregate state is just going to leverage those methods of the data sketches class. So the sketch object here is directly from data sketches. I'm calling this method here from data sketches. And then when I run my accumulates, I'm just going to update that data sketch with the data that's coming through the UDAF. So you can see here, my entire UDF handler is actually shorter than the one we were doing for average, because I'm really letting all the heavy lifting being taken care of by the data sketches library. So my accumulate here, I'm just updating the data sketch with the incoming data. And then when I merge these together, similarly, I'm just doing a union of the other data sketch with the existing data sketch. And data sketches already has built-in functions for all of these. So I'm just sort of plumbing together the data sketches library with the aggregate functions interface, and then leaving all of the heavy lifting to the library. And then finally, the finish method is really just a no-op. I'm just passing through what's coming from the data sketches library here. And then just like before, I create this using the Python API. And now I can call this on, in this case, I'm using a data set that's much larger than the few rows that we had in the last example. And so when I run this guy, it's going to take a little bit longer because I think there's maybe a few million rows on this data set. So it's going to calculate that data sketch across all of those rows. The heavy lifting is still left to the data sketches library. So for me as a user, it was a little bit easier to implement this and calculate the data sketch across those. And then for this particular example using data sketches, we also have a blog post that Felipe wrote about a month ago that goes into this example in a little more depth, and then also compares this to using user-defined table functions, which some of our more advanced Snowpark users might be familiar with. And that was previously how you could do these types of custom aggregates with Python. But of course, table functions weren't always the best tool for that job, because you'd always have to end that operation with a partition by one. And so you didn't quite get the parallelism benefits that you get with user-defined aggregate functions. So we can drop Felipe's blog post in the show notes. It's a great read, and it compares how you might have done this previously with a table function to using aggregate functions. And it shows the performance benefits that come from using the aggregate function interface.
This is awesome. I mean, so I love also that you have these multiple examples. I think showing the data sketch, implementation here and how you can leverage, all of the packages in the Snowflake Anaconda channel is really powerful. And I also love the fact that it's in dark mode. We have dark
Yeah.
mode in Snowflake now. So I love that too. This is fantastic. So I think, really from here, right, where should people go to learn more and get started with Python user-defined aggregate functions? I know we have the blog post that we have. We also have this documentation page on docs.snowflake.com, developer guides here, and that shows kind of how to use UDAFs for data frames in Python. And the last one is the Python API reference, which is also in the docs under the developer tab. And so from here, I also want to open it up for general questions from the audience. This is a true live stream. So feel free to ask questions, all about the user-defined Python user-defined aggregate functions, local testing in Python. A lot of new stuff here at Snowflake, and I love seeing the level of and attention to detail for the developer experience. So this is also just a big thank you, Jason, for all the work that you do on Snowflake.
Yeah, of course. Yeah, definitely those 2 documentation articles are great places to get started. In this example, I was using, of course, notebooks to create that UDAF and create it as a permanent object in my Snowflake account. But you can just as well import the Snowflake Snowpark Python package locally. And then you could be using VS Code as well to write that class that we saw for aggregate functions. And then you can also use the Python package like we saw in my notebook cell to create that as a permanent object in your Snowflake account. And you can do the whole demo I just did with, say, a Jupyter notebook locally, if that's your preference, or from really any other editing interface. So there's a lot of flexibility with Snowpark, and we try as best we can to meet developers where they are. And so, yeah, if there's any questions in the chat, feel free to reach out. And I'm always available on LinkedIn as well.
Fantastic. Well, with that then, what are one question for you, Jason, while we wait for questions from the audience is, so you mentioned a really cool customer story with on how a certain use case with Python aggregate user-defined functions. What would you say is the most do you have any other cool stories for us on customer use cases around how they're how maybe they've changed or improved their data pipeline now using Python user-defined aggregate functions?
Yeah. I mean, user-defined aggregate functions, there are a couple use cases in financial areas where we had customers that were using them to calculate more nuanced revenue statistics that we don't have built-in functions for in Snowflake. So we've been seeing a lot of use cases in finance for user-defined aggregate functions because it gives you a little more control and a little more nuance over how you calculate certain averages and statistics. And then with the local testing framework, an interesting use case that we saw, ironically, also in finance was JP Morgan Chase. They needed a way to be able to run their Snowpark Python tests in an isolated lockdown environment. Think of like a Jenkins CI environment. They don't allow any network access, and so they want that to be able to run Snowpark Python tests without connecting to a Snowflake account. And so that's an area where the local testing framework became an option for them to run those tests without needing to connect to the internet at all, or for that matter, their own Snowflake account. So it's always interesting to see how even more use cases come through the woodwork as sort of the base implementation for features get out there. And we love hearing it. And I'm always excited to evolve these features more. One thing that we're looking at right now for aggregate functions is implementing a vectorized interface for them. So if you've used Snowpark UDFs or UDTFs before, you might be familiar with this, where there's a vectorized version of those, where you take effectively batches of rows of data as pandas data frames. And we've seen that a lot of our customers like using those because, like most Python developers, they're used to using pandas. Pandas are just so popular. And so writing your UDF in a fashion where you're using pandas primitives and pandas data frames can make it a lot easier to implement. And so likewise, we have vectorized interfaces for UDFs, UDTFs, and we're looking at now how to bring that also to aggregate functions. So if anybody has particular interest in that, feel free to reach out. I'm available on LinkedIn. Also just jason.freeberg@snowflake.com. Always happy to chat with anybody that's using Python and Snowflake.
Fantastic. Fantastic. Well, I want to say a big thank you, Jason, for joining me here today on the live stream. I know I have learned a lot about all the things that that we're doing in this space, and I love seeing these hands-on demos, and especially all of the customer stories. I mean, like I said earlier, it really helps to connect the concept with with the reality of how it's used. And so this has been great. And for everybody in the audience, be sure and check out all of the getting started material. This is going to be key. We have the blog posts that talk about both the announcements for local testing and how to get started there. Also for the Python user-defined aggregate functions blog post as well, which again, by the way, is GA officially earlier this week. So that's fantastic. So with that, big thank you to everybody, and we'll see you next time.
Thank you.